Hey, let's look at some bus trans mods. I've blown a couple of these bus trannies up, so I'm just going to share some of this stuff that I'm doing to increase the strength of it and accuracy based on shifting. And vans never shifted very well to begin with, and then you put it into a sedan chassis, and then you got a drop linkage or on top of the tunnel linkage, and there's still a little bit of misalignments. So what I did with mine was I actually lowered the transmission in the chassis about 3/4 of an inch, and I'm not too worried about ground clearance, but anyways, by lowering it, then that brought more of a straighter line between the shifting fork, or pardon me, the shifter rod, and the shift shaft that goes into the end of the transmission. So looking at this rear of the transmission while it's open, one thing you check for is you move the main shaft on the other end in and out and make sure this portion of the bearing is not moving in the case. You can also push back and forth on it and see if it's moving in the case. Problem is, what happens is when these are in gear selections between the main shaft and the gear shaft, the gears want to walk apart. So if the case is worn or moves, or the input shaft of the transmission is walking here because this bearing moves and is wearing into the rear cover, which is not on at the moment, then of course you get misalignment in the gear connection at the front, and it usually guts teeth off of the transmission or the gears. So, and I've had some problems here, and each time I do something different to try and make it a little bit better, and so we'll see where we get to with this one. So what I do here is I box in the selector gate shaft, and these shafts just float in here, and when you select up and down your positions wherever you're going for whichever gear range, this shaft tends to walk out and it butts up against the case, and it almost comes right out of the end of the hole in the bracket. So there's the base bracket, and I've got some spares obviously from other transmissions, and what I did was I just cut it and carved it to follow this profile right here, and then welded it in on the top so it boxes it all in. So when it's boxed in like that, then it doesn't move as much, which gives you more positive engagement here with the selector shaft. They're kind of a bugger to do. I welded this one on the bench, and then you have to thread the bolts in at the same time. The next thing here is in the top, there is a bushing, looks like that. That's actually like a nylon or a Bakelite type material bushing, and it wears in the center, and then that causes misalignment of the hockey stick, if you want to call it the hockey stick. It's actually the selector rod that goes engagement with the relay that moves the selector shafts, so which pictures your gear range. So if you take a look at this thing, how it fits on here, and you see it's kind of sloppy Joe, and I don't know, man, off-roading with a nylon one, it's kind of scary. So I had a beefier transmission, and it had a steel bearing in it, or steel bushing if you want to call it. It's got an annulus groove around the center, allows for a little bit of lube to happen in there. It fits very nice on the shaft. Actually, sorry, not this one. The brand new one I just put in here fits very nice on the shaft. It's super snug. This one you can see it's all over the map. And I want to show you here, if you look at the one side, it doesn't look too bad as far as how true it is. You can kind of see it there. Okay, if you flip it over and look at that thing, it's just like oblonged all over the place. All right, so that gets replaced. That's about $20. It's a billet steel one. It shouldn't wear out as quick. So again, better positive engagement here, because the shifter comes, or the shaft comes through here like this, and then you select ranges by moving it accordingly. So if you've got a lot of play in this thing here like this, then you're not going to have as much of positive engagement, and that's what you're trying to do, because like I said, on the bus they're a little complicated. So the next thing you do is, again, make sure this bearing is tight in the case, and this one's tight in the case. It's not moving. If it's good, you can move your relay rods or your selector shaft rods, and then you can check the gear ranges, turn the input shaft, And again, look for very little in and out play on the input shaft. There's got to be a little bit there, but you'll see it here on the bearing, but hopefully not at this point. The next thing you do here is you put in what's called a stiffener plate. And it's a plate that looks like this. And basically it just slips right over top of the bolts or the studs, and it encases that bearing. It also cages this bearing somewhat, and then brings some steel rigidity to the back portion of the case so there isn't as much movement. Now, the cover goes on top of that, and this section on the cover, sorry, shaky camera, this section on the cover right here, this is what is actually controls your end float on the end housing of that bearing. So the problem is that shaft is not really supposed to have end float, but this kind of cages it so that it doesn't have end float. Problem is this part of the case wears. If you see wear in here when you take the cover off, it's a problem. If you see the bearing moving, it's a problem. So with this plate, it's 45 thou thick. And I had 40 thou machined off of this case end cover so that it brings it very close back within 5 thou, just to give it an extra little bit of crush on there. I got a nice new clean mating surface for the pressure on the end of the bearing on this new plate. And then when it's all together with the selector shaft in place, of course, it goes like this. All right, so the next thing here is I've done on the inside of this one already is I've changed this split bushing in here. They're a bit of a bugger to drive in. I used zip ties on it and then just tapped it in and then let the zip ties come off as I pushed it through the case. And then I'll have to, which I haven't done as of yet, put in the other end bushing. Okay, so it goes in, and then there's a seal that goes in the end of it. And then of course that encases the entire shaft. And make sure the shaft is clean. This is just an old used one here that I pulled out of the pile just to show you. You want to make sure that this area here and here is not worn out, because you can see this one, there's wear. Sorry, you can see it on this one. Maybe you can, maybe you can't, but there's a lot more wear here, and there's actually some wear into that shaft. So that again, even with the new bushings, is going to cause a little bit of misalignment, and the idea here is to try to create as much alignment as possible to reduce the amount of impedance on your ability to shift, especially if you jam them hard. And I don't know, this is my third bus tranny I've blown up from I guess abuse, and the last one was breaking in my 2276 stroker, and I decided to step side the clutch with a 2,300 pound clutch in it, running 33 1250s on the back, and it just decided to destroy that. So anyways, this is a little bit more of a beef up on it. And again, here's the old, and I've switched out the bell housing because I'm using a sliding collar throat bearing as opposed to the old style, which is that one right there. Okay. So I pulled this one off and I put on a sliding collar style. So a couple things to take a look at while you're rebuilding and installing your bus transmission.